This is the first video of a series that are meant to support the course FED 101, and I would like to explain the first component in this series about the Protoboard, and so called because this is the element that you will be using to investigate the concept and the realization of a circuit that is a result of some design, or you want just to analyze somebody else's circuit to see what it can do and how it does it. And it's called Protoboard because that's the component you'll be using to build the prototype of that circuit. The ultimate result, of course, will be later. Once you are satisfied with the characteristic of that circuit, then you build the PC board that will make it a permanent fixture of the circuit that is the basis of some product, or even into an integrated circuit if you want miniaturization, or you know for sure that you're going to be selling a large volume of that circuit. In this case, what we see here is two terminals. Depending on the number of strips you may have, in this case I have only two strips, 1, 2. You may purchase a board from IEEE store that may have 3 strips in case you want to build bigger circuits or keep some circuits while adding other circuits to analyze. But in this case, you see here two terminals that are meant to be used to connect usually this protoboard to a power supply, possibly even a generator. And in this case, you see one black terminal, one red terminal. So if it is about power supplies, then what happens is that usually the black is the ground terminal, or 0 volt, relatively speaking, of course, unless it's ground, it's earth ground. And this is usually the positive of the power supply. Sometimes you may have more than 2 terminals, like 4 terminals. You could have maybe plus or minus power supplies. You have different values, could be plus and minus 12 and 5 volts. Who knows what the circuit may require. And before, you see that these terminals have one plastic piece at the bottom, and then you will see in the back there is another plastic piece together with the nut, right? So what you will see is that these boards have some circles with a flat side, and the same thing happens with these plastic pieces. They have some little plastic that protrudes from those pieces, just to make sure that they fit here, so that when you tighten it, they don't move anymore, right? They don't turn around, or when you try to twist them or untwist them. Why twisting and untwisting? Because in this case, you will see that when you untwist or unscrew this top portion of the terminal, there is a hole here where you can insert a wire so that you can connect them to the protoboard itself, or to the strips, right? And so in this case, what I did is I connected the red terminal to the red line and the black terminal to the blue line. And therefore, when I connect my power supply here, using cables that are either terminated with banana plugs or alligator clips, depending on banana, they would be inserted directly into these terminals, and clips, they would be just clipping into the terminal, but you make sure that they go deep enough to touch the metal inside so that you have power to the circuit. Now, as you see here, you see this protoboard. It has 2 strips. In this case, each one terminated by 2 strips of blue and red lines. Now, that means all these holes for the entire line are connected together underneath the board, right? And the same thing with the blue line. All these holes, this entire line is connected underneath. However, as far as the strip is concerned, the columns are connected together. The holes in the column are connected together. But each column is independent of the other columns and definitely independent of these columns, right? So a column here would have only 5 holes, in which case that when you connect 2 components to the same column, it's as if you tighten them together, as if you tied them together, as if you soldered them together. So that makes the connections much easier. And of course, you can use wires to make longer connections from two different components in different parts of the circuit. In the old boards, these lines would be interrupted in the middle. So it means half and half only, right? And they're independent of each other. But in this case, the whole line is connected. In addition, you see here I have pre-wired the board so that all the blue lines are connected to each other. See, blue to blue, then from blue to blue, then from blue to blue. And then the blue is connected to ground, which means wherever I want to have access to ground, I connect the component to the blue line. This blue line, this blue line, this blue line, this blue line, doesn't matter. Why? Because we want our wires to be as short as possible. So if a component here needs a ground connection, then I connect it straight here and there'll be a short wire. Why? Because it will be easier to investigate in case you have to debug it, in case there are problems, in case you have to rewire it. Then it's easier to visualize when the wires are short and fewer, right? And fewer. And so, and in addition, you have all these gaps, which are called gutters, right? And you will see that these are intended to make it easy to connect ICs, right? They just straddle the gap and they fit exactly in the holes beyond, above, and below, right? Of course, as I said before, they're independent from each other. So when you connect them, when you put your component in there, then you know for sure that it will not be short-circuited or what have you. I know in some cases when the students don't pay attention, they put the IC here. But of course, anytime you have a pin, 2 pins connect to the same hole, it's like a short circuit, right? Because they're connected to each other. So in this case, that's what makes them independent of each other. And of course, you will have, after the 6th, 7th, 7th week, you will be working with ICs, and in fact, this whole board will be filled with populated with components, right? Especially for the class project, and it will not be difficult by that time. It will be something that you can master easily. But most importantly here is that if I want a component to be connected, so I connect one terminal here, I can connect another device, another component to the same column. So when I connect them to the same column, it's as if I tied these 2 terminals together or soldered them together. Right? And then you can put the other terminal wherever. Of course, you have to follow the circuit diagram to know where the components go, and they're connected to what in that circuit. In addition, you have also wires, right? If I want, for example, this point of connection between these 2 components to be connected to some other component somewhere else. Let's say I have another device, another component that is connected here, right? And somehow it was part of another part of the circuit that is where I could not get the component all the way here. So I could just take a wire, and when I connect this wire to this column and this column, it's as if I connected this terminal to these 2 terminals, right? So you will become master of this Protoboard pretty soon after the 1st or 2nd experiment. And in the meantime, you may be making mistakes, but believe me, after the end of the semester, you will feel like you're an engineer already. And of course, with time, you will see that when we deal with microcontrollers, it's like an entire computer on a simple board. And so you will have very few connections there because most of the work is done inside the processor. right? And the only wires you need are for something about the outside world, whether they are sensors, LEDs, or what have you, that need to be controlled, or that you will use sensors to control what the microprocessor will do or the processor will do. So in the meantime, this is the end of this video, and if you have any questions, please ask your instructor, and you will be provided with more information as we go.